You can take some notes on the front sheet. All right. Here are the wonderful problem-solving steps associated with any physics problem, or actually any math problem, frankly. The good news is I give you all the equations, so you just need to know how to use them. Right, the first step, and I want to talk about the first two steps today to sort of get you thinking about the fact that there are multiple ways of identifying this stuff and presenting it. It's just a question of how you go about doing it. And I really don't care how you do it, how you present the information or anything else, just that you do it. Okay, I will give you my preferences and I'll tell you why I think it works, but it isn't always the the way to do it. All right, so the first one is read the problem. And I always say read it twice, read it 3 times, read it 5 times, read it however many times you have to do to get the right amount of data. Okay? To be able to identify all the knowns and unknown variables. All right? Number 2, sketch the problem. Now, if you look at the first problem, right, it says Thumper runs across the ice at 5 meters per second, comes to a stop, and 3 seconds later, what was his acceleration? All right, when we talk about sketching the problem, we're not talking about creating the world's best rabbit picture, okay? I'm not an artist. I know I'm not an artist. Okay? This sucks. Don't do it. I don't want the nice big pond. Okay? I'm not looking for that. Here's the rabbit. Okay? It's a nice box. Okay? He runs across at 5 meters per second. Right? We know he comes to a stop. Now, he's starting. We identify initial with a 0, which says original. So, the original velocity. You'll hear it talked about as V naught, though. Okay? So that little thing means not, but it's an O. It stands for original. Okay? So he's running across right? He comes to a stop at some time later, right? So this is t, the original time, which is 0. Final time, 3 seconds, right? 3 seconds. All right, now, here's where you need to get out your physics to English dictionary. Okay, and a lot of people are really struggle with words that are being told. Okay, it says he comes to a stop. What does comes to a stop mean? He's got to, okay, so that tells you that the sign of the acceleration is most likely going to be negative, but you don't know what the value, the magnitude is. You know the direction, but you don't know the magnitude. All right, what else do you know? Comes to a stop. What does that tell you? Yeah, the velocity at time t equals 3 is 0 meters per second. Okay? That is one way to identify knowns, unknowns. All right? You know what your known values are? Sure. You know the unknown. Right here. Okay? Everything's there. All right? Another way, people draw the pictures. You know, they sketch it just here. And then what they do is they start with a list. Simply a list of the variables. So they're going to have a V naught equals 5 meters per second. T naught equals 0. They'll say T is 3 seconds, and they'll say that V is 0 meters per second, and then they'll simply write acceleration equals negative that, okay? Now, both work just fine, no problems whatsoever. The way a lot of my students do it, which is slightly different, not right, not wrong, they build a before and after table, okay? So here are your before. So these are the original values. and here are the, we'll call them final for a lack of a better, so the befores and the afters. All right, you have your displacement, your velocity, your acceleration, and your time. All right, now acceleration is always going to be constant. If acceleration changes, you build a new table. Okay, so my original displacement, make it your reference point. You know, if you can make something 0 to make your math easier, do it. Okay, your initial velocity, 5 meters per second. Your final velocity, 0 meters per second. You're looking for the acceleration, so that's a big empty blank. And your times are 0 and 3 seconds. In this problem, what else can I ask you for? Yeah, I could ask you the final displacement. Okay? They're all perfectly fine. It does not matter. And I don't care. Okay? I want to see a sketch, labeled or not, and I want to see the variables, the known and unknown variables. Okay? Most of my students tend to go this way. Just because they fill out the table, they know what the knowns are, they know what the unknowns are. Is it right? Is it wrong? It's there. Okay? All right, so let's look at this next one. All right, we have a car. It's advertised to travel from 0 to 60 miles per hour in 8 seconds. How far does it go in that time? All right, so let's start again. Here's your car. It's an excellent car, isn't it? You should see what my car looks like. It's worse than the rabbit. All right, we know it goes from zero, all right, to 60 miles per hour. And we know the time interval is 8 seconds. Okay? Okay, and they want to know the displacement. So they're looking for that final position. So in here we're looking at, okay, 80 to 90% of the time, your initial displacement is 0, your initial time is 0. And I will work hard to make that happen. Okay? So I've got 0 and 60. All right? And we have 8. And in this case, it's looking for the final displacement. Because I said this was 0. So whatever value this final position is, that's my answer. Now, we have a little issue here. We always want the equations that we're going to be learning next class, Tuesday, is we're going to have to deal with all of our values, velocities, okay? So displacement is in meters, velocity is in meters per second, acceleration is in meters per second squared, and time is in seconds. Okay? These are the units that it must be in, regardless of what values I give you. Which means what? Unit conversions. All right? So you're going to have to do some unit conversions in these problems. It's the way life is. Okay? Acceleration sometimes is given to you in G's. All right? And G's is just a percentage of gravity. Okay? Gravity has a value of 9.8 meters per second squared down in the metric system. Okay? Now, all right. Any questions so far? No? Pretty good? Easy? All right, so let's look at this next one. All right, here's where it gets, where you can start playing tricks to make the math easier. Okay? So the next one says there's a set of keys dropped from a 40-foot high bridge. All right, so we know that the ground is at 0 meters. Everybody knows ground is 0, right? The height is 40 meters. Okay? It tells you, what does it mean when it says it's dropped?
Falling.
Yeah, it's falling. What?
Isn't it 40 feet not the way?
Gravity is an acceleration. So we're looking at an acceleration of 9.8 meters per second squared down.
Miss Taylor, it's 40 feet.
40 feet?
Yeah.
Thank you. Okay, so we're going to have to do a little conversion there. What else do you know? Something says it's dropped.
It's right at 0.
Right. It tells you that the initial velocity is 0 meters per second, feet per second, whatever you want to call it. And they're asking what the velocity is right here. Okay? Now, what I'm going to do is I'm going to turn it upside down. Okay? I am going to make this 0, and I'm going to make this 40 feet. Okay? So I am going to make down my positive direction because my math gets so much easier. All right, so when I do this, I still have an initial velocity of 0 meters per second. I have an acceleration of plus 9.8 meters per second squared. I'm still looking for my final velocity. My initial displacement is now 0 feet or meters. And my final displacement is 40 feet. Of course, now I'm going to convert that. Right, 12 inches is 1 foot. And then 2.54 centimeters in 1 inch. And then 100 centimeters in 1 meter, whatever that value is, right? I'm going to do that conversion. Before I do anything else, I'm going to do all my conversions. Okay? So I have identified all my knowns and all my unknowns. My displacement, I have a positive displacement. I have a positive acceleration, so I do not have to worry about when I start evaluating numbers and making sure that I'm, if I'm dividing by a negative, it's still, negative by a negative is positive. It's all positive. I've made that easier. I just have it there. Okay? So part of the goal in physics is use your logic. Make your math easier. Man, some people call it lazy. I call it efficient. If you can be efficient, do it. Okay? All right. The last one. All right, so the last one, again, we have that lovely car. Perfect. You want to see how my car looks? Looks more like a spaceship. But don't you think my rabbit is better than my car? Those people do. That's why blocks are really my favorite. So we know that it goes from rest, right? And it's going some distance, right? Okay? And it's reaching 40 meters per second, but it's accelerating at 5 miles per hour per second. Okay? So I have another one of those wonderful unit conversions, right? 5 miles per hour times seconds. Right? So 5,280 feet in 1 mile. 12 inches, 1 foot. 2.54 centimeters in 1 inch. And then finally, 100 centimeters in 1 meter. But then I have to convert hours to seconds, right? And there are, in 1 hour, 3,600 seconds. So I'm going to do all that math, right? So if I were going back and filling in a table, right? I'm going to do all that, and then I would just put that right here. So this is acceleration. Okay? Does that make sense to everyone? So how many people feel like they're going to fall into the draw the picture and label the points category? Anybody? I know you're going to have to work with it and play with it, and that's fine. All right, how many people are just going to go into this list category? Still got to draw a picture, it doesn't matter. How about this table? A lot of people seem to, but you see, the way I like the table is because it tells you what I'm going to ask you for in the problem. And I honestly do not care as long as you do one of them. If you find something that works for you that is not one of these three, use it, okay? If you want to ask me if I think it's going to work, go for it. But I'm definitely not one of those people that my way or the highway, okay? If you ever find me that way, I want you to confront me on it. Okay, I want you to do it the way it works for you. All right? So any questions about this? I know it's fairly straightforward, but I've spent a lot of time looking at a lot of different videos out there, and every video does this, it might do this, it might do some other combination, but I wanted to present you with all of them so you kind of knew what your options are. All right? All right, so homework tonight for Tuesday, since we don't have class on Monday. Monday's an evening. Friday you don't have class. All right, is to do the problems on the reverse side. All I'm asking you to do, sketch it, read it, sketch it, and identify the known and unknown variables. However you want to do it, or mix thereof, just to get one that you're comfortable with. All right? That's it.